Hi everyone. So my name is Jacques Le Mancq. I am the CEO of Broadpeak. Broadpeak provides CDN and streaming technology to telecom operators, cable companies, content providers in different regions. We have some offices in France, in Singapore, São Paulo, and now New York City. So I'm going to talk about live television, live HTTP, live multi-screen, or ABR format. So everybody's talking about live, but what is it really? So what we're seeing is that everything related to the pay TV has been done around a set-top box, bringing a lot of scalability. But now with an iPad, you can get a very nice user experience. But what about scalability? So that's what I'm going to talk about. If you have 1 million people watching live HTTP content, it's going to put a lot of pressure on your network. So how do you make it so that you can reach all the screens but still remain cost-effective? So we realized that problem in 2012 during the Olympics in London. And we look at the traffic, and on this graph you can see that the red part is the on-demand content, and the live part, the green part is the live content. So you can see that the live OTT traffic is not too good for your network. At peak, the live represented already 7 times the on-demand content. So let's say if you have a telco network, a cable network, and you're provisioning your capacity only for on-demand, then you're in trouble. And we've seen that with time, people are using more and more their iPad, their connected devices to enjoy the live events. And maybe you've seen it for yourself. Usually, when it's not too important, it works. But when it's important and we have critical events, then this is when it doesn't work. So it's very frustrating. So why is it not working today when everybody's watching? Well, one of the reasons is that live HTTP traffic is very bad for the network in the sense that if you look at this map where you have one core node and 3 regions that you see there, if you want to deliver live content to 1 million people simultaneously, and you have your 3 regions, you will probably put caches in each of the regions, which is good for your core network. But your edge network is going to be saturated because all that traffic has to go through the backhaul, through the access networks, and this is where it hurts. Even if you are dividing into regions, you will have 1 terabit per second per region, so it's going to congest your network, it's going to make it hurt, and as a consequence, the quality of experience will be bad and degraded, especially when everybody's watching. So what can you do about it? Well, what you can do about it is that you can throw money at the problem. So that's, and I don't have a problem with that. We provide ourselves some cache servers. So if you're a telco, a cable company, and you want to put hundreds of streamers in your network, that's fine with us. But then you have to upgrade the core networks, the backhaul, the access. You have to replace all the CMTSs or the DSLAMs. And then it costs a lot. And when you're done doing this, you have to do it again. Because as we see every day, consumption of live traffic is not going away. Okay? So throwing money and throwing capacity at it is probably not the smallest way. And it is not a cost-effective way anyhow. So especially when we know you've probably had a lot of conferences about monetizing content and monetizing live events. So if you're still struggling monetizing and you have to invest a lot, then it may be a problem. So what we're saying live as a characteristic. Live is about everybody watching the same thing at the same time. So there's nothing new into it, There is a way to send live to end users. You can do it the broadcast way, okay? So or the multicast way for people who are doing IPTV. So if you're a telco, a cable company, or even a satellite provider, you have a network that is able to do multicast or broadcast. And you also have deployed millions of, let's say, cable modems, broadband gateways, Wi-Fi routers, set-top boxes. According to Infonetics, operators have spent $7 billion last year for CPE devices that they own and that they put in every home. So if you consider a CPE, like a cable modem, a broadband gateway, Wi-Fi router, or a set-top box, it's got some CPU, it's got some storage, a little amount of storage. So if you think about it, it's like a very small data center. Let's call it a nano data center. And if you run a CDN function on it, like caching features, now you have a nanoCDN. So that's really the concept of it. And for live, the way you can leverage this is that you can take your live ABR content, your live HTTP content, whether it's HLS, smooth, or dash, and you can send it as multicast all the way down to the CPE devices. And then in that modem or router or set-top box, you will be able to turn it back to unicast. That way you can reach all the connected devices who support only HTTP while saving a lot in your network. So if we see the impact of this way of doing things on the network, now if you take that stream, that live HLS or live smooth or live dash, and make it available as multicast in your network, you can see that you're not using anymore your backhaul or your core nodes or even your access, okay? So if you have 1 million sessions or 1 million people watching live television using HTTP, now it's going to be only a few megabits onto your network, only a few megabits of multicast traffic. And it changes everything, because now the traffic generated or related to live content is not a function of the number of users anymore. It's back to a function of the number of channels. So it's very much scalable. So then you have to wonder if using multicast ABR, the fact that you take that live content and make it available as multicast in your network until the very last place into the home. Let's see how it works with the different challenges. So in terms of how cost effective it is, so because you're reusing your gateways, or your modems, or your set-top boxes, well, you're not spending any money there, okay? So no CapEx there associated. All you have to do is put a software piece in there. Because you're reusing the capacity of your network to do multicast or broadcast, well, same thing here, you don't need to invest anything there. So, and since there is no peak effect on your network, you don't need to upgrade your access, or you don't need to do it right now, so you can postpone that investment. In terms of security, pay TV is about security, of course, so if your content is not secured, then you're not going to generate revenue, and it's even worse, nobody will want to work with you, so of course, security is key. And when you use a multicast ABR technology, when you push the fragments as multicast to the home, you're not doing anything to the security. You're not touching the DRM. You're not messing with it so that you don't introduce any risk there. So you make your content providers feel confident, and you ensure that people will pay for content. Finally, multi-screen is about making it working with everybody. And with every screen. So you don't want to have multi-screen solutions that will work with only, 30% of the Android versions. We all know about the Android fragmentation. And it's very important when you optimize your network that it will still work with every device. And in the case of multicast ABR, your iPad or your Android device or your HDMI stick will still be connected to an HTTP server, except that HTTP server is not in your network anymore. Now it's in your home. It doesn't know it, that's it, but it's still an HTTP server. So by doing this, you make sure that it will work with any type of device. You don't need to do anything to your application. So it's very critical there. And in terms of user experience, you need to check a couple of things. So, like, for example, the startup time. Nobody wants to wait for the video to start, because if you wait too much, you're going to get bored, and you will want to change to another channel, or to another service. So by doing multicast to the edge, you can introduce some latency, but by using bursting unicast, to start your session, then you can reduce the impact on the starting time, so that there is no impact at all. You can actually be faster. In terms of the adaptive bitrate feature, we all know it's critical. Everybody's used to it now. There is a lot of competition for services in the network, but also in the home. We are coming now to an era where you want to watch something in like a game, and you have to tell your kids to turn off the iPad because they're eating all the bandwidth in the home. So what you want when you do some optimization to your network, you still want to maintain all the adaptive features, so that if you move away from the access point, or if other people in your home are using the network, then you want it to go to a different profile, to gear shift to a lower profile, or gear shift to a higher profile. So we maintain all those features by being able to send one multicast per profile. The time shifting feature, that's key. When you're watching live, you want to be able to pause, maybe you're answering the phone. So optimizing the network needs to save these features of time shifting. So by using the storage that you have in the set-top box or the cable modem or the broadband gateway, you can still do the time shifting in the home. And even if you don't have enough space in the home, then it will go back to the network. So it seamlessly works in that sense. It doesn't change that feature either, so still available. Low latency. So I am not a big PSG fan, but I know some people, some friends of mine, they love soccer. And sometimes I go to their place, so we have some beers, we watch the game. And we don't want to hear the neighbor like shouting when there is a goal or something like 3 seconds before, 5 seconds before. I mean, if they shout for the goal, it's okay before so that you get one, you get excited. But if you start being excited by the action and then you hear something like, oh, so you will lose all interest in the game. So it's very important that the latency remains as small as possible. So. And finally, if content is king, quality is definitely queen. So quality is making the big difference. If you use a multicast ABR technology, because you will free your network from unnecessary traffic, you will reduce the congestion, and as a consequence, you will get a better quality, higher profile, average, and most of the time. So a good way to guarantee a better quality is also to do multicast here. So this nanoCDN technology works for everybody. It works for cable networks. It works for telecom networks, and it actually also works with satellites. So we started with cable operators and telecom companies, but now we're getting into deployments with satellite operators who have now a way also to reach all the different screens. Because usually pay TV operators, they can reach only the main screen, and they have a hard time dealing with the second screens, all the iPads and everything. But if you use it for satellite, for example, we know that the cost of a CDN service is equivalent to satellite capacity when you reach 25,000 simultaneous subscribers. So it's also a good enabler for satellite now. So the way we work, just to explain, because we provide technology to, you understand that, so to enable the multicast ABR. And the way we do that is that we give away our agent. So we are not a non-profit organization, but we give away our agent so that our partners can integrate it into different devices. So we can work with middleware vendors, with set-top box and home gateways providers or chipset vendors. We give them the software, we test it in the lab, and we certify it. So we have created a vehicle for that. It's called the Broadpeak Open Alliance, and we have some founding members, including people like Technicolor. Technicolor, you probably know, it's a leader in cable modem, broadband gateways, and set-top boxes. We work also with SoftAtom. They are the provider of middleware for the Orange Group, both on the set-top boxes and broadband gateways. And we work also with AirTies, who have a very interesting technology to improve Wi-Fi coverage in the home, by the use of mesh technology. So we work with of course, we work with other partners also, but the idea is that we make it available to your suppliers so that you don't need to buy additional hardware. This is it for me. So thank you again for listening here. So you can meet us on our booth at BJ308. So it's in the basement of Communicasia, and we have a live demo there. We have also some representative from our Singapore office. Julian will be happy to meet you there. So, and again, I'm happy to answer any question if there is any.
Fantastic. Look at this. This timekeeping's exceptional today. Is anyone going to ask a question? Because I do have a question to ask. You talk about low delay. I'm always interested in these OTT applications. How much of the delay that you experience for live services are you in control of? And how much of it is down to sort of network delay, buffering on the laptop and so forth? Because that's really the challenge for sort of live delivery of those services. Do you have any benchmark figures in that area?
Yeah. So I don't have a magic number, I'm sorry. We should have prepared this question. But in terms of the latency, yes, like you said, there are several parameters, like the encoding parameter. If you're into a mobile environment, you want to have large buffers, so you see chunks of 10 seconds or so. What we see mostly is that everybody doing HLS now is moving down to 2 seconds, very similar to the smooth streaming. So you cannot go really below that latency of 2 seconds, because you need to get that chunk. You cannot go back, into the future or something. So you need that latency. And after that, it depends how the player deal with that. So, for example, on our booth, we have a demo with a Zenterio set-top box, and they do they have some strategies to display the first picture very fast. So it's like 2 seconds only, I know that the iPhone is pretty good also at getting the first picture, but depending on the implementation, some Android applications, for example, they can wait for 3 chunks or 6 seconds. So it really varies there, but you're right, there is a good margin for improvement to make sure that you reduce as much as possible. But again, there is no magic. You will probably not go below these 2 seconds that are necessary for having, the aligned profiles at 2 seconds. So.
Oh, very good answer. Right, it's your last opportunity before coffee time. Anyone got a question?
Any question?
All right then. Well, we've done well. Thank you very much, and thanks to the speakers for keeping on time.